Okay, so you've got your containers up and running. Awesome, but that's really just step one, isn't it? The real art, the real craft, is in managing them, debugging them, and just understanding what they're doing out there in the wild. Today, we're going to arm you with the essential commands you need to go way beyond Docker run and become a true master of your containers.
To really get what's happening in modern operations, you have to get your head around this pets versus cattle analogy. Back in the day, we treated our servers like beloved pets. We gave them names, we nursed them back to health when they got sick. Not anymore. Today, containers are cattle. They're numerous, they're identical, and most importantly, they're replaceable. If one has a problem, you don't waste time fixing it, you just get a new one. This isn't just a small technical tweak, it's a complete revolution in how we think about operations.
Right. And that brings us to the real-world problem with the whole cattle model. Yeah, the ultimate goal is just to replace a faulty container. But you can't just terminate it the second something looks wrong. You've got to figure out why it got sick in the first place, or it's just going to happen again to the next one. You have to become a sort of container veterinarian, and every good vet needs their toolkit.
So our first set of tools is all about active intervention. This is for those times when you need to roll up your sleeves, get your hands dirty, and see exactly what's going on under the hood of a running container.
Here's the classic scenario. We've all been there. An application is just stuck. It's not responding, but the container itself is technically still running. It's a total black box. The command that pries open that box for us is docker exec.
Now, this is where it gets really cool, because this reveals the central theme for today. Docker isn't magic, it's just a brilliant abstraction. Docker exec works by using a powerful Linux kernel feature called setns. It's a system call that basically tells the kernel, hey, see this new process I'm starting? I want you to put it inside the exact same isolated world as that other container that's already running. You're literally teleporting a new process into an existing universe. How cool is that?
You've probably typed docker exec-it thousands of times without even thinking about it. But what are the I and the T actually doing? Well, think of it like making a phone call. The I flag, for interactive, keeps the line open. It keeps standard input open so you can actually talk back and forth. Without it, the shell would just hang up on you immediately. And the T flag? That allocates the sudo tty, which basically makes the connection feel like a real terminal. It formats the text, gives you a proper command prompt, lets you use arrow keys, Control-C, the whole deal. Together, they create that seamless shell we all know and love.
Okay, so we've used exec to get a shell inside the container. We're in. The next logical question is, what's actually running in here? For that, we turn to Docker top.
And this right here visualizes a core concept of containers that you have to understand. Thanks to kernel namespaces, every single process lives a double life. Inside its own little container world, your app is king. It's process ID 1, the first and most important process. But from the host machine's point of view, it's just another process in a long list, with some high-numbered PID like 11,677. Docker top is the command that lets us see that host-side reality and translate between these two worlds.
All right, let's switch gears. We've been talking about actively getting inside the container. Now let's talk about passive observation. Sometimes you don't want to disturb anything. You just want to monitor the container's health and see how it's behaving from the outside. Think of this as your operator's dashboard.
Oh man, this is the question every operator asks themselves at some point. Is this container the reason my whole server is slowing down? To get a live streaming answer to that very question, we use Docker stats.
Now here's a super important thing to remember about memory. Don't panic when you see high usage. The Linux kernel is really smart. It loves to use any free RAM it can find for file caching just to speed things up. But that cache can be reclaimed instantly if an application needs it, and the beauty of Docker stats is that it knows this. It reports the container's memory usage minus that cache, giving you a much more accurate picture of the actual memory pressure your app is creating.
So stats gives you the live vitals, but Docker inspect, that gives you the container's entire life story. Think of it as its birth certificate, its ID card, and its architectural blueprint all rolled into one. It holds every single detail about how it was configured, from network settings and IP addresses to volume mounts and environment variables. It is the absolute source of truth.
Let's be honest, running Docker inspect by itself just dumps a giant, intimidating wall of JSON on your screen. The real power is unlocked with that little -format flag. Using Go template syntax, you can pinpoint and pull out the exact piece of information you need.
This transforms Docker Inspect from a simple inspection tool into a cornerstone of automation and scripting. This is how you manage cattle at scale.
Next up, let's talk about control. We're moving beyond just looking at containers and into commands that actively manage their long-term behavior, their life cycle, and how we get data in and out of their isolated worlds.
So what happens when a critical container crashes at 3 a.m.? Restart policies are basically your automated first responders. They're simple but powerful instructions you give the Docker daemon on what to do when a container stops. It's a crucial first line of defense for keeping your services available.
Okay, pay attention to this one, because the difference between always and unless stopped is subtle but absolutely vital. Imagine you Docker stop a container to do some maintenance, and then the whole server unexpectedly reboots. If you used always, that container is going to pop right back up, probably interrupting what you were doing. But unless stopped is smarter. It respects your manual decision. It says, nope, an operator stopped this on purpose, so I'm going to leave it stopped. It's a small detail that can save you from a major headache.
Sooner or later, you're going to need to get files into a container or pull log files out. The tool for that job is Docker CP. But it's not just a simple copy-paste. Under the hood, Docker is actually creating a tar archive of your files, streaming it across that isolation boundary, and then extracting it on the other side. It's another one of those clever abstractions that handles all the complexity for you.
All right, in our final section, let's talk about identity and packaging. In this fast-moving world of ephemeral cattle, how do we package them up so we can move them around? And how do we give them a stable name so they can find each other? These are really central questions for building any kind of reliable system.
Okay, this one trips people up all the time, so let's make it super clear. The key difference is this. Docker Save is for images. It bundles up the entire image with all its layers, history, and metadata into a single file so you can move it to another machine. Docker Export, on the other hand, is for containers. It takes the live file system of a running container and squashes it down into a single, flat layer, throwing away all the history. Two different tools for two very different jobs.
Renaming a container might seem like a small, cosmetic change, but it's actually incredibly powerful. See, when you run containers on the same network, Docker gives you a built-in DNS service so they can find each other by name. Docker Rename lets you update that address book on the fly. It's a key piece of the puzzle for simple service discovery, allowing containers to talk to each other without caring about their ever-changing IP addresses.
So as we wrap this up, the big idea I want you to walk away with is that none of this is Docker magic. Docker exec is using kernel namespaces. Docker stats is a friendly face for cgroups. These simple, elegant commands are really just well-designed doorways into the powerful, battle-tested engine room of the Linux kernel itself.
And this all brings us to a final thought. These abstractions, they make us incredibly fast and productive. But when things go wrong in strange and unexpected ways, and they always do, it's that deeper understanding of the system underneath that makes us resilient. It's great to know how to drive the car, but it's invaluable to know what's actually happening under the hood. So as you go on, I really encourage you to pop the hood every now and then. You might be surprised at what you learn. Thanks for joining me.